All right, for 78, it's saying, well, we could also make a tree diagram here. But the problem with the tree diagram is it makes it look like all of the events are equally likely. So all right, so here it looks like when we are at this spot, the probability of each of those letters is the same. So how could we reflect the true probabilities of each? So what Sabrina's doing is she's writing the probability of each of them next to it. So for example, the probability of A was really 1/3, and T was 1/4. Now, the tricky part here is you need to remember that you are multiplying these. That's why the area model is kind of nice, because it's a rectangle. So hopefully you'll realize, oh, rectangle, base times height. But you have to remember here, if you're going to make a tree diagram, that you're going to multiply the branches. So that would be 1/12. So according to your area model, what was the probability of AT? If I look up here, probability of spelling the word at was 1/12. And look, if we multiply those probabilities, we're going to get the same thing. All right. So all we had to do for B was just label it on the tree diagram. And then for C, we wrote 1/12 based on the area model. And did we get the same thing with the tree diagram? Yes. Does this method work for all the combinations? Similarly, calculate the probability for each path in the tree diagram. At the end of each branch, write its probability. Do your answers match from what we did in the area model? Okay, so A would be 1/2, U would be 1/6, and then T is 1/4, 3/4, 1/4, 3/4, 1/4, 3/4. Okay, so this, it would be 1/8. If would be 3/8. UT would be 1/24. UF would be 3/24. And all I'm doing is just multiplying the branches. And then here would be 3/12. Do your answers match? Yes. And yes. So you should have the same probabilities for each.